Okay guys, so we're going to talk about polynomials for just a little bit. There's so much to talk about polynomials, but I'm just going to give you the main things. So we've got coefficients, those are the numbers that are with the variables like x and x squared and x to the third and so on. We have the degree, which is the highest power that the x is being raised to, or the variable is being raised to for that matter. You have the lead coefficient, that's the variable with the highest power. So the degree, it's the coefficient for that degree variable. And just some basic things you need to know about polynomials is that the power itself has to be an integer, meaning it has to be 1, 2, 3, 4, 5, 6. Has to be positive integer or 0. It could be 0 because if there's no x, that's perfectly fine. It could be a constant that still counts towards being a polynomial. And polynomials have different shapes. If you have x, just an x, you have what we know as a line. If you have x squared, you guys know that as a parabola. If you have x to the third, you have this graph, which is kind of like more like an S. It might not drop down as much. In fact, it might look something more like this. Okay, it has two curves. You might have one that looks like this. It could be the same degree. This is x to the third as well. If we go to x to the fourth, you get kind of a more W-looking shape. It has a curve here, here, and here. If you do it again, we have something that looks something like that. Curve here, here, and here. This is x to the fourth. This is negative x to the fourth. It may not even look like that, actually. It may look more like a parabola still, but it could be x to the fourth. The curve could just be very small right there in the middle. We have x to the fifth, and it goes something like this. Okay, that's one version. This is the x to the fifth, and then if I do the other one, it goes something like that. That's negative x to the fifth, meaning negative coefficient, obviously. And so these can have very different formulas. So let's look real quick. If I give you x to the third minus x squared, 2x plus 4, for instance, and I asked you which graph does this most closely resemble, well, you see an x squared there, you might think, oh, this is a parabola. But because the lead coefficient is 3, that means it is actually one of these ones, x to the third, negative x to the third. It's actually more closer to that one. And it just has a different shape. It may be more like this shape, where it dips down a little bit further, or it may even be worse than this. It may look more like a straight line. I don't know off the top of my head. And so there's lots of things you can do with these. And to do these things, there's just a couple of rules that you have to know. So if n is odd, so that means if you have a to the n, x to the n, and this power is odd, so if you have x to the third, x to the fifth, x to the seventh, x to the first, then it is increasing on both ends. So, I'm sorry, no, it is decreasing on one side, increasing on the other. So what I mean by that is if you look from the center, it's decreasing to the left and increasing to the right. If you're looking from the center, the most central point. Okay? If that's for the line x. If you have x to the third, decreasing to the left of this most center part, increasing to the right. Okay, and that's when they're odd. Now, that changes if it's negative. If it's negative, then it is the opposite. It is increasing on the right, decreasing on the left. Or, I'm sorry, increasing on the left, decreasing on the right. Sorry, I said that backwards. Okay, so then that takes care of that. The negative just flips that order. Now, if you have, these are for n is odd. If you have n is even, though, that's your parabolas. Your x to the fourth, x to the sixth. Okay, 1, 2, 3, 4. So there's always one less curve than there is power, the highest power. So if it's x to the 6th, there's going to be 5 curves. If it's x to the 2nd, there's 1 curve, and so on and so forth. So if n is even and an is positive, increasing on both ends, both left and right, from the most center point. So if I go to here, increase, increase. If I go to here, it is increasing, increasing. Here, increasing, increase. And so you can see that it is increasing basically over the domain of it, for most of it, the majority of it. Okay. And then obviously if you have an is negative, then it is decreasing on both. So let's draw that. We have a parabola. We have that one. This is x to the 4th negative. Okay, and so on and so forth. So always look at the highest degree, or the degree of the polynomial, to decide what shape it should be. And then obviously you can decide from there. So we're going to actually graph one of these. Or we'll try. Let's get the zeros of this thing, and you might wonder how. X to the 3rd plus 3x squared minus x minus 3 equals 0. Well, we're going to use grouping, so let's separate this. This is x squared, x plus 3. And we can factor out a negative 1, x plus 3. Okay, so this factors out as x squared minus 1, x plus 3, because we're factoring this out from both of those, and that leaves this there. Okay, so then we have x plus 1, x minus 1, if you recognize that, x plus 3. And so x equals 1, negative 1, and negative 3. So if I have a graph, I'm going to have 1, negative 1. Here's 1. Here's negative 1, and here is negative 3. Okay, so we've got 3 points on the graph already. Let's decide from the most center point, is it increasing or decreasing left and right? So let's look. It's x to the 3rd. So that's something like this, or something like that. And because it's positive, we know it looks more like this. Decreasing on the left, increasing on the right. I'm busy. I'm going. It's decreasing on the left, increasing on the right. And so we know that it does something like the following. Okay. And that is how you would graph this. I'm not going to worry about all these points. I just want you to know that it's decreasing on the most left point. So that's all I did. I went to the left side. It's decreasing here, increasing on the right. Now, how do I know it's above this curve? Well, because if it was below it, then it would have to come back through this, and it wouldn't make sense. If these powers, if these are to the 1, then it crosses through it. If the degree of these is 2, so for instance, if you had x plus 1 squared as factor of it, it would hit that point and it would come back down and it wouldn't go through it. So that's another rule or trick that you can use when you're doing these. Obviously, if you have more questions, we can do them. I'll do another example in another video. And thank you guys for watching. I'll post another video here soon.